metals are shiny, malleable, able to be pounded into thin sheet, ductile, able to be stretched into wires, and good conductors of heat and electricity. Most metals are solid, but mercury is metal that is a liquid at room temperature. In the periodic table, metals are grouped to the left and dark step-like line that starts in group 13 and ends in group 16.
Okay. So metals, nonmetals, and metalloids. You should have studied this more in depth in 6th grade. Okay. Just a review, metals, you need to know that they're shiny. They're normally shiny. They're malleable. That means we can beat them down and change their shape and bend them. Okay. They're ductile. That means they can be stretched into wires. That's why most of your wires are going to be made out of metal. And they're good conductors of heat and electricity. Okay. Metals are going to be located to the left of that dark step-like line. So you just asked about this dark line. So let's go back to our periodic table. And I'm going to extend this dark line up because it said to the left of the dark line that these are all metals. So everything on this side of this line, see how it stair steps down through the periodic table? Everything on the left of that dark line are metals. Now, all metals are solids except for one. It said that mercury, number 80 right here, is a liquid at room temperature. So put a little L in that box for liquid. All right, let's go back and read about nonmetals. Adrian, you want to read about nonmetals?
Nonmetals include all elements in group 17 and 18 and those groups from 14, 15, and 16 located above or to the right of the step-like line. Solid nonmetals are generally dull-looking and brittle and do not conduct heat and electricity well. Many nonmetals are gases at room temperature. One nonmetal is a liquid at room temperature.
Okay, so nonmetals are just the opposite of metals. It says they're dull looking. They're not shiny. They're brittle. They will break easily, so we couldn't beat them and shape them and bend them. And they do not conduct heat or electricity well. It says they're located on the right of that step-like line. And it said most are gases, but we do have one liquid. So let's go to our periodic table. So to the right of that line, everything on this side is nonmetals. That one liquid is bromine. It's number 35 right here, so put a L. And it said most of them are gases. So I want to label which ones are gases. First off, we know that this whole column are the noble gases, right? So they must all be gases. So put a G down all of column 18, or the noble gases. The other gases are 7, 8, and 9, nitrogen, oxygen, and fluorine. 17, chlorine. And that's all. The rest are solids. Okay, let's go back and read about metalloids real fast. Metalloids. Nikki?
Metalloids have some characteristics of both metals and nonmetals. Many metalloids are semiconductors caused the metalloids are located along the step-like line near the right side of the periodic table in groups 13, 14, 15, and 16. They include boron, silicon, germanium, arsenic,
Okay, so our metalloids, they're kind of in the middle. They can't decide if they want to be a metal or a non-metal, so they kind of have characteristics of both. Okay, so typically you'll see that they are semiconductors, which means kind of like partial, or partial would be like halfways or part of the way. Okay, so they're semiconductors. They're semi-malleable. They're semi-ductile. So it's kind of like just riding the fence. They're not picking a side if they're going to be metal or non-metal. They're located along the step-like line. And then it gave you some examples of what they were. So let's go back to our periodic table and look at where these metalloids are. Now, we're going to color code our periodic table. We're going to color metals, nonmetals, and metalloids. So in order to do that, we need a key at the top. So I want you to draw 4 boxes, actually. The first box is going to be our metals. Next box, make it the metalloid. Then, third box will be the nonmetals. And then we're actually going to color code more nonmetals. They're going to be special nonmetals. They are the noble gases. And I'll show you how we're going to do that. So you'll need 2 different colors. Metals are going to stay white. We're not going to color them because there's a bunch of them. So all of these, even all of these down here, these are all metals. So we're just going to leave them white. Your metalloids, I'm going to choose my lighter color and shade in this box. So I'm going to color all of my metalloids orange. Now they said they were along this line. So if you start at the top, it's every element above the line. So boron, silicon, arsenic, tellurium, and astatine. But then it's also the ones below it except for aluminum. Aluminum's a metal. So if you start at the bottom, it's everyone below it. Polonium, antimony, germanium, not aluminum.
Wait, we're supposed to color inside them?
We're going to, yeah. So now you're going to shade them in. I'm going to color them orange. You can shade them any color. Just make sure it matches your key. My key says my metalloids are orange. So, there's my metalloids. Next, I'm going to color my nonmetals. Now, all of my nonmetals are blue. That's everything on this side. But I have a special group here, the noble gases. They are still nonmetals. So they're still going to be blue. I'm just going to color the noble gases darker, a dark blue, so that we know those are the noble gases. And then all the others just kind of a shaded lighter colored blue. Okay, because noble gases are still nonmetals. Noble gases is the column 18, group 18, family 18, or you could call it noble gases. They can be referred to any of those names. Okay, then I'm going to shade the rest of my nonmetals kind of a lighter colored blue. So that would be everything else on this side of the step-like line, on this side of the orange metalloids. So this is what your periodic table should look like now. There is one more thing I want to add here. If you look at the bottom here, the lanthanide series and the actinide series, these actually fit into the periodic table right here in between these two. And the reason they don't put them there is because it would just make your periodic table really, really long. So they cut them out and put them here. So if you notice, it goes 55, 56, well then 57 jumps down here. Goes all the way to 70, and then it jumps back up here to 71. So basically they just took these two rows out from right here so that your periodic table wasn't so long. Okay, and the only thing I want to add, this isn't really anything you'll be quizzed on, but since we're completing our chart, let's complete it right. The lanthanide series has 3 valence electrons, and the actinide has 3 to 6. It varies. Okay, so for homework, you are going to finish reading about chemical properties of chemical families. I'm going to underline right now the key important points. That doesn't mean you don't read everything else. You still read it all, you just make sure you really understand the points that I underlined. Okay, a chemical property is, underline it now with me, how it reacts with another substance. Flammability is an example of a chemical property. Reactivity, one of your vocabulary words this week, is also an example. Okay? And actually I'm going to circle these vocabulary. Reactivity is how likely an element is to form bonds with other elements. Remember when we talked about forming ions? That is what forming bonds means. That's how reactive they are. You look at the valence electrons, those are the electrons on the outermost energy level, to tell how reactive they are. Okay, that means the groups, because remember groups go up and down, they're the valence electrons, the number of valence electrons are all the same. That means the groups will have similar chemical properties, because chemical properties, the number of valence electrons tells me their reactivity. So each group, the up and down groups, will have similar chemical properties.